All right, good evening and welcome to Master Talker online class. We are still on our video on solving Math 111, Physics 111 question. And if today is your first day of watching our video, please click that subscribe button so that anytime I drop a video on maths, physics, and chemistry, you will be the first person to be notified. And don't forget that this channel is all about WAEC, JAMB, NECO, and university, mostly university questions. Okay, mostly university questions. So, but one or two times we talk about WAEC and NECO and the rest. Okay, so the first question here, question number 31, said a turn a turntable a turntable, okay, of radius 10 cm, okay, rotates at an angular acceleration of 4 rad per sec square, okay, at they say at the end of 3 seconds. Okay, they now say we should calculate the angular speed. Okay, solution. Don't forget that equation summation say that v is equal to what? U plus at. If you now convert it to circular motion, v now will now turn to angular velocity. So angular velocity omega is equal to what? Initial angular velocity plus what? Plus alpha t, where your alpha is what? Your angular acceleration. So if you now put it, you now have that w will now be 0 plus what? Your alpha, which is angular acceleration, is 4 rad per sec square. So I'm going to have 4 times my time is 3. So my angular speed is now what? 12 rad per sec. Okay, this is very, very simple question. We move to question number 32. Question number 32. Question number 32 said a particle of mass 0.05 gram, okay, is rotating about vertical axis, okay, 10 cm from it. Then I say if the body completes two revolutions every 3 seconds, then I say calculate moment of inertia and the frequency of rotation. Okay, solution. So let's bring out our parameters. The first thing they gave us is mass, and the mass they gave us is 0.05 gram, which is what? 0.05 divided by 1000. To convert it to kilogram, we are going to have 0.05 divided by 1000. So I'm going to have 0.12345 kilogram. Okay, so the next thing they gave us is the radius. The radius is the rotation. That's what they gave us. So they gave us radius as what? 10 cm. So if you convert it now, you are going to have 10 divided by 100, which is 0.1 meters. Okay, so the next thing they gave us there, what else did they give us? Okay, so then I say we should calculate moment of inertia. Don't forget that moment of inertia is simply the summation of what? mr squared. So if we use mr squared, forget the summation. So my m is what? So using mr squared, I'm going to have 0.00005 times 0.1 all squared. So I'm going to have, if you do everything and then tell me your answer. So I'm going to have times 0.1 times another 0.1. So I'm going to have 0.1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think it should be 6. Let's check your own. 5 moment of inertia. What's the SI unit? So find the SI unit. This is kilogram per meter square. Kilogram meter square. Okay, kilogram meter square. So you can find the, so now to find the frequency F is what? How many revolution did they give us? They say 2 revolution in 3 seconds. 2 revolution in what? 3 seconds, which is what? 2 over 3 revolution per sec. So the form the unit of frequency is what? Revolution per sec. So this is very, very simple. We move to the next question. Question number 33. Please use your calculator to check this thing because I am not with a very nice calculator. Okay, so question number 33. Question number 33 said the expression for moment of inertia of a bar of length L and mass m about a point passing through one end is, okay, so the moment of inertia about a point passing through one end. Solution, we are going to have that, let's say that this is a bar, okay, and I have my this at this point, okay, at one end. Okay, let's say that this is at this end. Okay, so this is my dx. So I'm going to have that change in moment of inertia is equal to what? M over L dx. Okay, then times x squared. So you have to know this formula. This formula is very, very important. Okay, that change in moment of inertia. Or if you don't want to know how to, I'm just deriving it, but I will tell you the answer. After deriving, you will not see the answer. It's either you just cram the answer, because this question comes out every year. Okay, if you just know the answer, you tick it if it's objective. But if not, you can just learn how to derive it. Okay, so I have that that change of this is equal to this. So the change in this is equal to m over L dx, then times your x squared. So I'm going to have that this is what? Change in moment of inertia is equal to what? M over L x squared dx. Now, change means differentiation. So differentiation going to the other side becomes integration. So I'm having this is equal to the integral from 0 to that L. Okay, from 0 to that L of that M over L x squared dx. So I'm going to have that this is equal to, this is a constant. The only variable here is x. So if I bring it outside, m over L, the integral of 0 to L of x squared dx. Okay, this is equal to what? M over L into, integration said add 1 to the power and divide by the same power. So I'm going to have x raised to power 2 plus 1 is 3 divided by the same 3. Okay, don't forget that I'm still moving from my 0 to L. Okay, so this will now be equal to, m over 3L if this 3 is coming outside. So I am left with, the only person I'm left with, x raised to power 3, but the starting from my L, don't forget, to 0. So this is equal to, substitute L first. So I'm having m over 3L into, let me substitute, L raised to power 3 minus, then substitute 0, 0 raised to power 3. Okay, I substituted L first before substituting 0. So I'm going to have m over 3L into, this and this will give you L raised to power 3. Okay, so this cancel one of these. So my answer becomes ML2 over 3. So this is the expression. Okay, this is the expression you are asked to find. It's very, very simple. So even if you don't know how to get the expression by yourself, so what do? The only thing you do is simply by knowing knowing that is ml squared over this. That is if it is at one end. But there is a question that they will ask you that do comes out in exam. Permit me to clean here, where they will say that it is at the middle. If they say that it is at the middle, the only thing you do is that it is no longer coming from 0 to L. It will now be, listen, let's say they say that it is now from the middle, okay? They say that the expression for the moment of inertia of a bar of length L and mass M about a point passing through the middle, okay? They will tell you that it is passing through the middle. So what do you do? It's the same thing here. You just say that what? That change in I is equal to what? M over L dx, then times x squared. So you now have that what? Change in I is equal to M over L x squared dx. So whenever differentiation crosses to the other side, becomes integration. So I have I is equal to the integral. Now, because they say it passes through the middle, it will now be minus L over 2 and L over 2. That's just the difference. This one is just that from the zero end to the other end. So from 0 to L, okay? But in this one, if it is at the middle, it will not be minus this over this. So I'm going to have what? My M over L x squared dx, okay? So this is going to be, bring out the constant outside, have M over L, the integral of minus L over 2 of x squared dx. Okay, the integral of x squared dx, starting from minus L over 2 to L over 2. So if I now integrate, I'm going to have M over L into the integral of this is what? X raised to power 3 over 3. Add 1 to the power, divide by the power. Don't forget that I'm still moving from my minus L over 2 to my L over 2. So I'm going to have M over what? 3L into my x raised to power 3. This is my L over 2 minus L over 2. So which will now be M over 3L into, now substitute. First thing I'm substituting is what? L over 2 all cube minus into minus L over 2 all cube. You put this one there minus this one. That is how we do integration that has points. The up minus the down. So I'm going to have my M over 3L into, this one will give you L raised to power 3 over 8. This one will now give you minus to make it plus, because minus raised to power odd number, the minus will still remain. With this minus becomes plus. So I'm going to have L raised to power 3 over 8 again. So if you add this, you are going to have M over what? 3L into 2L raised to power 3 over 8, because they are the same thing. 1 plus 1 is 2. So, but this can take care of this to have 4. So this can take care of one of these to have 2. So my final answer when it is in the middle is what? ML squared over 12. So if it's in the middle, just know that it is over 12. But if it is at the end, just know that it is over 3. Okay? So at the end, you have over 3, but at the middle, you have over 12. So that is just the difference between the two of them. Okay? So that is that for question number 33. We move to question number 34. Sorry about that. So question number 34 said, question number 34. 34 said, look at this. Question number 34 said that d squared y over the r squared plus w squared y is equal to 0. They say this equation describe what? This is a simple harmonic equation. Okay? Simple harmonic motion equation. So this equation is for simple harmonic motion. So 35, question number 35 said a pendulum has a period of 6 seconds, okay, period of 6 seconds, and amplitude of 8 cm. The amplitude is the radius, so they say we should calculate the what? Velocity and the acceleration, okay, at the end of the swing. Okay, so this is very, very simple. To calculate the velocity, we are going to have that this is I think, okay, let us get our parameters first. Solution. The first thing they gave us is the they gave us the period. The period they gave us is 6 seconds. Okay. The next thing they gave us is the amplitude. The amplitude is the radius. The radius is equal to what? 8 cm. Okay. And but they say we should calculate the velocity and acceleration at the end of the swing. So if it is at the end of the swing, then our y will still be the same 8 cm. It is complete at the end of the swing. So our y will still be what? 8 cm. So you now remember that your velocity will now be what? 2 pi over what? 2 pi over t, the square root of what? Which is it y that comes with r? Yes, r squared minus y squared. This is a very important formula you need to know. Okay, so this is v is equal to what? 2 times 3.142 divided by what? 6. Then the square root of what? 8 squared minus 8 squared. Now everything here is giving me 0 meter per second, because here is 0. 0 times everything is 0. Okay, so the next thing you are calculating is your what? The next thing you are calculating is your acceleration. And the acceleration, to calculate the acceleration, you're going to have that your acceleration A is equal to what? Omega squared y. Okay, omega squared y. And don't forget that your omega is simply what? 2 pi. This is omega. This is supposed to be omega. This is the same thing as what? Just omega the square root of what? R squared minus y squared. So and omega is equal to what? 2 pi over t. Then my y. So which is what? 2 times 3.142. Okay, all over 6. Don't forget that there is squared here. All squared times my 8. So I'm going to have, so solve that with your calculator and get your final answer. Okay, I'm going to have 3.142 times 2 divided by 6. Okay, times the same answer. I don't have a good calculator, so just if you press inside there, square it, then do this, you are going to get your answer. Now sometimes they will tell you that calculate the velocity and the acceleration at a particular length. They can tell you at 3 cm or at 4 cm or at 5 cm. You now know that your y is that length they gave you. But if they say at the end, then your y will be equal to your r. So that is one thing you need to know here. Okay, so question number 36. Question number 35, sorry. Question number 35. Okay, I just solved question number 35. So question number 36. Question number 36 said from first principle derive the dimension of universal gravitational constant G, and hence write down the SI units of measurement. Okay, so this is a very, very simple question. We know that our G, the gravitational constant, first of all, solution, we know that our F is equal to what? G m over what? R squared. And we know that our G, to make it subject, our G will now be what? F R squared. Okay, all over what? M. In fact, m will give you m squared. All right, or let me leave it as m. Okay, then I have that my force is still mass times acceleration. Then I have my r squared all over what? M. So this take care of this. I'm going to have that my kg, my mass is down. So my capital letter mass should be down. So because it's down, I'm going to put -1 because it's down. Now I have acceleration is meter per second square. So that meter is L, per second square is time. Then I'm going to have that my radius is another L squared. So L here and L here will give me M -1, T -2, L minus L3. Okay, so that is that. This is the dimension. Then the unit, from here I can get the unit. The unit is what? Newton meter squared per kg squared. Okay, so that is that for that. So we move to question number 37. When we get to 40, we stop. Question number 37. Let me check my time. Question number 37. Okay, 20 minutes. Question number 37. We are moving. Question number 37 said that F is equal to G M1 M2 over R squared, comma, where G is universal gravitational constant, comma, then our M1 and M2 are masses. Okay, our masses, and our R is the distance apart. Okay, then I say the law in physics having such mathematical expression was given by Isaac Newton. Yes, it was given by a man called Isaac Newton. Okay, that is for question number 37. So that is by Sir Isaac Newton. So the answer here is Sir Isaac Newton. Okay, so that is that. So move to question number 38. So question number 38 said the slope, 38 said the slope of a distance, of a displacement time graph is, then I say illustrate with a diagram. Now if I have displacement and the time, displacement is measured in meter and then my time is measured in second. If I have something like this, I'm going to have that my slope is this. So here is change in s, where here is change in time. So I know that my slope is equal to what? Change in displacement over change in time. And what formula will give you change in displacement over change in time, which is what? Velocity. So velocity is the slope. Velocity is equal to change in displacement over change in what? Over change in time, which is equal to the slope. So the slope of velocity time graph is velocity. The slope of velocity time graph is velocity. Okay, we move to question number 39. Question number 39. Question number 39 said a train moving with a velocity 72 kilometer per hour is brought to rest by applying brake in 5 seconds. Then I say calculate the retardation. Calculate the retardation and distance traveled during the period. Okay, solution. Now the first thing they gave us is what? They gave us, it was at our initial velocity they gave us was what? 72 kilometer per hour, which is what? 72 times 1000 divided by 60 times 60. So if you do that, you're going to have question number 37, which will give you 20 meter per second, 20 meter per second. So the next thing they gave us is time. They gave us time as what? 5 seconds. Okay, I know that my v is equal to what? U plus at, and then I know that my final velocity is 0 meter per second. Yeah, because it is retarding, it's going to stop, so the final velocity will be 0. So I have what? 0 is equal to what? 20. Okay, plus my a, I'm looking for my a, then times my 5. So this one moving here, I'm going to have that minus 5a is equal to 20. So my a will now be what? 20 divided by minus 5, which is what? 4 times 5 to minus 4 meter per second square. Now, The answer is just 4. The minus I got shows that it is retardation. Okay, the minus you are seeing here shows that we got retardation, and that is what they are asking us here, the retardation. So the next thing they are asking us is the distance. I know that formula for distance, s is equal to ut plus what, half at squared. So we now do that s is equal to what, my u initial velocity there is 20. So I have that 20 times my minus 4. Okay, sorry, my time there is what, my time is 5. Okay, plus 1 over 2, because retardation I'm going to use minus 4, it is retardation, and then my time is 5 squared. So I'm going to have 5 squared. So I'm going to have this time, this will give you 2 times 5, 10, 100. And then I'm going to have 25 times 2 will give you 50. So minus 50, which will give you what, 50 meters. Okay, so that is that. So we'll go to the last question for this particular video. Question number 4. They say write 3 examples of vector quantities. So just know, so tell us that one in the comment section. That one is for you. 3 examples of vector quantities. Any quantity that has both magnitude and direction. So thank you very much for watching. Please like, share, and subscribe. Comment what you think is the answer for the three vector quantities you know. Okay, let me give you one. Velocity. Bye bye.